This sequence is about limiting reagents and the balanced chemical equation. We mixed two chemicals together and reacted them, and we're asking, is there a best mixture of moles, how to find it, and what it means. The question, which our experiment tried to answer, is, does any mixture of moles of two chemicals give an optimum reaction? And so we experimented with hydrogen burning in oxygen. We know from Avogadro that equal volumes of gases have equal numbers of molecules if they're at the same temperature and pressure. And we know then that the volume ratio and the mole ratio would be the same. So we started with all hydrogen, and then we added oxygen a little at a time, measuring the intensity of each reaction. You can use an acoustic measurement with a microphone to see how big the explosion is, or, as we did, you can use the distance the little rocket flies. Here is our experiment setup. We start with all hydrogen, no oxygen. We end with all no hydrogen and all oxygen. And we measured the distance flown. These are results from the year 2010. This is a plot of the numbers, the ordered series of points going up and going down. This is the ratio of hydrogen to oxygen. It appears that the optimum ratio, the peak here, is 2 to 1, 2 hydrogens to 1 oxygen, because this ratio is about 0.66. We hypothesize that this means 2 moles of hydrogen react exactly with 1 mole of oxygen. That's our hypothesis. With no hydrogen to oxidize, the oxygen molecules just bounce around. There is no energy, there is no flight of the rocket. Here we see that we have added some hydrogen. There is a reaction. We believe that whatever hydrogen was there needed 1/2 that amount of oxygen, and the rocket flew. With more hydrogen added, again, 2 volumes of hydrogen reacted with 1 volume of oxygen, and the rocket flew farther. With exactly 2 hydrogen molecules for each oxygen molecule, we hypothesize that we have the maximum distance. As you see, the average distance here was somewhat less than that. And that has to do with the setup of the experiment and the fact that students with no experience were doing it. As we add more hydrogen and remove oxygen, all the oxygen reacts, but not all the hydrogen. So the hydrogen is excessive here, as we've got more hydrogen than we need. And finally, with no oxygen and all hydrogen, there is no reaction and no release of energy. No sound, no motion. So, our hypothesis that 2 moles of hydrogen react with 1 mole of oxygen is borne out by the experiment. And we've done this many times in the years since and have gotten very much similar results. Our hypothesis is good. It explains all the data and observations. That means that if we want to write a balanced chemical equation, we can say 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water, because 2 volumes of hydrogen react with 1 volume of oxygen to give us the maximum flight. This, of course, needs to be continually verified, but as we have done that, the results have been the same.